Okay, this video covers finding values under the normal curve, and we have a lot to cover in this video. We're going to find a z-score given the area under the normal curve, and we're going to find specific data values of a normal distribution given the probability. So what you know how to do is if you're given a normally distributed set of data and you know a certain x value, you can find the area under the curve that is to the left of that value, or you are finding the probability that that event will occur. Well, what we're going to do in this video today is I'm going to have normally distributed data, and I'm going to give you the probability of an event to occur, or the area under the curve, and you're going to find the x value that corresponds with that. So we'll start with the standard normal curve with z-scores. So say we wanted to find the z-score that corresponds to a cumulative area of 0.3632. When I'm talking about cumulative area, remember that's going from the left to the right. So 0.3632 would be in a standard curve if this is 0. 0.3632 being the area would be approximately here. So the area here is 0.3632, and we're trying to find the value right here, the z-score that corresponds with that area. So if you were using the standard normal curve distribution table, what you would do is you'd have to find 0.3632 on the table in here, and then find the z-score that corresponds to it. So kind of headachy. Let's see, I think it's, where are you, sucker? Oh, he's all the way down here. So here is negative 0.362. So the z-score that corresponds to it is negative 0.3 and 0.05 for a z-score of negative 0.35. In this class, you don't really need to use a table like this. We can just use our calculator. So I'll show you how to use your calculator to find the z-score. So before we use normal CDF to find the area under the curve that corresponds to a z-score, and now we're going to use what's called inverse norm to find a z-score that corresponds with an area. So we go second distribution. We go down to the third option, which is inverse norm, and in there you're going to put your area. So our area is 0.3632, and close parentheses and press enter, and we get negative 0.34918, blah blah blah. And so we'll be rounding that to three significant figures, which is actually negative 0.350, which is the same answer we got when we used the table. Okay, so we'll do the second problem right here, where we're going to find the z-score that has 10.75% of the distribution's area to its right. So we're going to draw a picture like we're doing for all these problems, and we're going to shade the area that we're interested in. And we're interested in this area right here of 10.75%, which actually, we should change that into a decimal, so 0.1075. So your calculator can only display information of a cumulative area coming from the left. So we need to calculate the area to the left of this z-score right here, even though we're just given information right here of the area to the right. So I need to tell the calculator this area to the left of the z-score. So the area under the curve has a total of 1. And if I subtract 0.1075 from 1, I would get the area of this red region right here. So 1 minus 0.1075 is 0.8925, and that's what I'm going to use when I want to find the z-score. Again, I just go to my calculator, I go second distribution, inverse norm, the third option, 0.8925, .8925. Press enter, and I get 1.24. And remember, I'm going to put my answer in 3 sig figs. So, also, and I didn't do this to the first one, but you're going to write what you put into your calculator just to make sure you can get full credit, just in case you get the wrong answer. So you're going to do inverse norm .8925, and we got, what did we get? And we got 1.24. You might be dealing with some problems. This might come up where we're dealing with percentiles, and percentiles is really the same exact idea as the area under the curve, or the probability of an event to occur. So if we want to find the z-score that corresponds with the 95th percentile, well, if I draw my little normal distribution right here, 95th percentile would be about here, and that's the area all here underneath the curve, represents 95% of, or 0.95 of the curve. So go to your calculator, you go second distribution, number 3, inverse norm, 0.95, close parentheses, enter, and you get 1.65. So I would draw my curve, and then I would write inverse norm 0.95, and then I would put down my answer, which is 1.65. So let's get to some application problems where we have normally distributed data, and we know the mean and the standard deviation, and we want to find certain values given area under the curve. So scores for a civil service exam are normally distributed with a mean of 75 and a standard deviation of 6.5. To be eligible for civil service employment, you must score in the top 5%. What is the lowest score you can earn and still be eligible for employment? So, here are some important pieces of information. We have the mean is 75. We have the standard deviation is 6.5. So here are the important pieces of information here. We have the mean and the standard deviation. So the mean is 75 and the standard deviation is 6.5. And when I draw my curve, what I'm interested in is what score, what is this value right here that represents the top 5% of the scores of the exam. So really, I'm really interested in, because we can only calculate cumulative areas starting from the left, I'm interested in the 95th percentile right here. Because your calculator, and even if you're using a table, can only uses cumulative area starting from the left. So if it's all the way on the right, you have to do 1 minus that area. We're going to use our inverse norm here, and we're going to do our area. We're going to do the mean and then the standard deviation, and that's going to give you us our x value. That would be, what are we answering? The lowest score you can earn and still be eligible for employment. So we go second distribution, number 3. We're going to put the area, which is 0.95, comma, the mean, comma, the standard deviation. And we get 85.7. So that's the lowest possible score, 85.7, that you can earn and still be eligible for employment. Okay, that's it for this video. Let me know if you have any questions.